Hi guys, welcome to the 5th video of the budget mini quad build series. I have the mini quad here on my computer desk, and hopefully you can see that I have the USB cable plugged into the CC3D. And what we need to do next is first of all install the USB driver for this connection to your computer. So if you just have a look on the computer here, the link for this page is in the video description below. And basically all you have to do is grab the correct driver for your operating system and install it. And really, if you're doing this kind of tutorial, you should know how to do that. If you don't, I'm sure there's plenty of other tutorials which will teach you how to install a driver for a Windows or a Mac or whatever flavor of computer you're using. So once all this is installed correctly, what you're going to see is the ST Microelectronics virtual COM port. If that has appeared in your device manager, you've done something right and you're good to go. One little tip I will tell you is that on this particular machine, which is running Windows 8.1, sometimes after a reboot or after plugging and unplugging the USB cable, this isn't automatically detected and we have to click the Scan for Hardware Changes button. I'm not really sure why it doesn't automatically detect it, but if it doesn't, just go into your device manager and click on that Scan for Hardware Changes, and normally it comes straight back up. So we have our flight controller communicating with our computer. Now, the next thing that I would suggest that we do is that we go to the Cleanflight firmware repo on GitHub, and again, I will link this down below, and we just scroll down and you can see all the different boards that Cleanflight is compatible with, and you can see here is CC3D bin, and that's what we want to download. So just click on that and we'll download that. Make sure that's in a place where you can find it later. Then next we need to download OpenPilot, but what we're actually going to do is just use OpenPilot to do the initial flash of the Cleanflight firmware. Now you can see here there's a latest release, and under the supported boards you can see that CC3D is nowhere to be mentioned. Now if you scroll down a little bit, you'll see note CC3D is not supported by this feature release. And this is another great reason for using Cleanflight, because it seems like the newer releases of OpenPilot are not even supporting the CC3D anymore. Here we go, release 15.0202. And we have the OpenPilot release for, in my case, Windows. So I want to go ahead and download that. And now the next thing we need to do is actually open up OpenPilot. And we need to go into the firmware tab, and we actually need to put the CC3D into rescue mode. Now actually I need to unplug and replug, and then you'll see it's detected that we've got our CC3D, and now we want to open the firmware file that we just downloaded. So here we have it, the Cleanflight CC3D. Click I know what I'm doing, and then click flash. And you can see here, it's pretty painless. And that's it. Now we have Cleanflight on the CC3D, and we don't ever need to worry about OpenPilot again. So we can close that. And now the next step is to install Cleanflight. And installing Cleanflight is very simple. Basically, you just need to search for Cleanflight and click on the GUI download. Again, I'll give you a link to this in the video description. You need to be using Google Chrome, sorry, is an important note. And mine's already installed, but if it wasn't installed, it would just say add extension or install app or something like that. So once you have it installed, you can launch Cleanflight. And now because we've just done the firmware flash, we need to unplug, replug, and here's a great example of where we need to do the scan for hardware changes. As soon as I did that scan, you can see it came up with COM5, which is our board. So let's try and connect. And there we go. Now we're connected to our CC3D on Cleanflight. That was pretty simple, nah? The reason why I went with Cleanflight instead of OpenPilot is just because I'm more familiar with it, and at this point, like, I don't really want to learn another, let's say, outdated firmware, although I'm sure there's a lot of fanboys that are going to yell at me for saying that. But anyway, Dominic, who is one of the main developers of Cleanflight, is very active, and you know, there's a lot of good stuff going on there. So I recommend Cleanflight at this point. So let's go across setup. You can calibrate your accelerometer, which I don't recommend you do when we have the CC3D not even mounted in the quad yet. Then we have our ports. For this particular setup, we don't need to worry about this. Now, the configuration page. We want to make sure that we're on quad X. And you can see here it's kind of cool and interesting. There's lots of different configurations you can build. After you've built this project, I'm certain that you're going to want to do more stuff, and it's pretty cool. The possibilities are kind of endless of what you can do. Now, super important one. We need to adjust minus 90 degrees on our yaw, because if you remember, we've turned the CC3D from its native forward position. So this is very, very important. If you don't do this, the quadcopter is probably just going to flip as soon as you try and take off on your maiden flight. Now, the next thing that's also super important is to make sure that parallel PWM is selected. And what this means is that those wires that we just hooked up from the receiver to the flight controller are each channel 1 through 6 in parallel. If you're using the FlySky stuff, the D4R2 and similar, you can use PPM, which sends all up to 8 channels over one wire, and this is really cool. For this setup, for our budget quad build, we're using parallel PWM. Spectrum 1024 is fine. RSSI, signal strength, we don't need to worry about. Fail-safe settings on signal loss, I would say just set that to 1400, just until we know, until the quad's calibrated. And what that means is if it loses a signal from the receiver, it's going to just put the throttle to 1400, which means it's not going to come crashing down, but it is going to come down to the ground, because hover should be 1500. GPS, we don't need to worry about that. ESC, I suggest that you enable motor stop, which means that the motors will not spin when the quad is armed. And this is really just a safety thing. Like, you don't really want the motors to just start spinning when you arm your quad in case you need to unplug a battery or do something. For me, it's better to just have this enabled. Your throttle parameters, for the moment, we can leave. Trims, we can leave. Battery voltage, we can leave, because our receiver and transmitter doesn't support telemetry. Current meter, we don't need to worry about. Actually, all of this stuff we don't need to worry about. So let's just go ahead and click save and reboot. Now our PID tuning, we don't need to worry about at this point. After our first maiden flight, we'll come back to this and worry about this. We just use it stock for now. And our receiver port, this is something that we're going to use very shortly. Now for right now, we want to go to our motor tab. And this is where we can test that our motors are all hooked up correctly. Now you can see here, now obviously this is super important. Do not have your props on when you do this motor test, because that would just be ridiculous. So yeah, remove the props, click yes, I am not a retard, I have removed the props. And now we can go through and manually wind up each motor. And yes, we've got motor 1 spinning. Yes, we've got motor 2 spinning. Yes, we've got motor 3. Yes, we've got motor 4. And let's give all of them a kick. Yeah, I mean, that's real good news. We've got everything going. So I would say if you've just done that test and you haven't got everything going, you need to go back and double check all your wiring. This has nothing to do with the receiver we just hooked up. You need to be fault finding between the CC3D flight controller and your ESCs, or between your ESCs and your motors. Basically, this test we've done has just proven that everything in that signal path is good. So now we want to go back to the receiver tab and have a look at our transmitter. Okay guys, so now let's have a look at the radio, and we can look at Cleanflight as well. At the moment, everything's on center, which is 1500. So if we've done everything right, when I turn this radio on, we should see a change in the channel values in Cleanflight. So let's try. Hey, and there we go. All right, so let's just have a look. So at the moment, this is on channel 1. This is on channel 4. This is on nothing. That's channel 2. That's aux 1, which is channel 5. And that's channel 3. Okay, so the good news is that we know that we've got our connection all set up correctly. What we do need to do now is set up the channel mapping on the radio so that the correct channels are mapped to the sticks according to how we want them mapped in Cleanflight. Okay guys, I've just had a complete shocker. First of all, I found out that there's something up with my CC3D where channel 6 doesn't seem to be working. And then second of all, I just filmed this whole bit that you're watching now and forgot to push record, so now I'm doing it again. So yay for me. So anyway, I've just sat down with this radio and learnt it so that I can teach you guys about it. And the good news is, it's very simple. There's basically, you hold down the menu button to go into the menu, and there's two menus. There's the system setup and there's the function setup. And basically the system setup is for setting global settings on the radio. So these settings affect every model, doesn't matter which model you've got selected. The radio can store 20 different models. And then the function setup is where you adjust the individual settings for each model. So let's first have a look at the system setup, and we just scroll to it and push. And you can see model select. Like I said, you can have 20 different models stored in. So that's just the way you can recall a different model. Then model name, you can go in there and you can see it's fairly intuitive. You can just rename. I've named mine ZMR250 because that's what it is. And just hit OK to confirm. Then type select. This one's kind of important and not so intuitive. Even though we've built a multi-rotor quadcopter, we need to make sure that it's on airplane mode. There's all sorts of helicopter modes in here, but this is not what we want, because the way a helicopter works is different and not the same as the way a multi-rotor works. Basically, your helicopter has servos that control the angle of the main rotor so that it can get forward thrust. And this is not the way that a multi-rotor works. So long story short, you want it set to aeroplane mode. Then model copy does exactly what you'd expect. It allows you to copy one model from one slot to another slot. Model reset does what it says on the tin. That will reset all your model settings, so don't accidentally hit that. Then trainer mode and student mode. This is, you can hook two radios up together, and you can have the one in student mode can be flying, and then if they're about to crash or do something stupid, the trainer can just grab the sticks and take over. Now, the other important one is sticks mode, and we go in and have a look, and you can see here that it tells us which channel the sticks are sending on to the receiver. So basically channel 3 is the thrust, channel 4 is the yaw, channel 2 is the pitch, and channel 1 is the roll. And this is the mode that we need on for our multi-rotor. So we just make sure it's on mode 2 and click OK. LCD brightness does what you'd expect, set it how you like. Firmware version, you can check the firmware. Mine's 2nd of March 2015, so that looks pretty new to me. Firmware update, you actually need a USB cable that is not shipped with the radio, so we can't do anything about that. And then also factory reset does exactly what you'd expect it to and will wipe your radio. So that's all well and good. We've been through the system menu. Now we have the setup menu. So we can go into the setup menu. And the first thing is reverse, which basically just allows you to reverse any of the servos. Now for a multi-rotor, this is not really very useful. Where it would be useful is if you had a servo wired in a plane and maybe one servo was going backwards or something like that. Save you rewiring it, you could just reverse it. Then we have our endpoints, which we will actually set up, and I will show you how to do that in a little bit. The display just gives you a nice readout of what the channels are doing, and it's a great way to confirm that actually your channels are assigned to the correct thing. You can see 3, 4, 2, 1, cancel out of that. And then we've got our auxiliary channels. And what this is if we go in and have a look, the first auxiliary channel, which is channel 5 on the receiver, I've got assigned to switch D. And this is going to be my arm and disarm switch. And then on the second auxiliary source, which is channel 6 on the receiver, I've got switch A, which is this one here, and that's going to be my flight mode, basically going between horizon mode and rate mode. Horizon mode is when the aircraft is auto stabilizing, and rate mode is the one you want if you want to be doing flips and acrobatic flying. So then we've got our sub trim. And what that does is set the center point of the control. And I will show you that more in depth coming up. Rates and expo is to do with the dead spot in the middle. I suggest you just leave that how it is for now. And then throttle curve, mix, elevon, all this stuff is basically good for airplanes and helicopters. And we don't really need to worry about any of that. So we're pretty much set up. I'm going to show you now how to correctly plug the receiver into the CC3D using Cleanflight to check what you're doing. And then I'm going to show you how to check your endpoints and your sub trims. And pretty much after that, we're ready to finish the assembly of the quadcopter and go for a fly. This is the bit that could be kind of confusing, but it's not really. What you need to do is, or what I've worked out, is that these wires coming out of the flight controller in this order are not actually the channel input order for some crazy strange reason. It may have something to do with the fact that Cleanflight is a port to this controller. Natively, this controller should be running OpenPilot, but we're kind of bodging Cleanflight into it. So I'm guessing it's got something to do with that. Whatever the reason is, it's pretty simple to work it out. So you can see here with the controller and the receiver and everything turned on and plugged into Cleanflight, you can see that we're receiving information on 5 of the channels. It should be 6, but like I said, I have a fault, and this channel 6 line here is doing absolutely squat diddly. I can plug it into any of the channels here and it doesn't do anything, and I can plug one of the known good channels in to output 6 and it does work. So basically it can't possibly be anything else except that. What we need to do on our controller is work out which channel was channel 1. And when we looked here on our radio and went into the function setup, there was the display page, and we can see here channel 1 is here. So if you just plug it in randomly, the best thing to do is just plug these in one at a time until the one that should be controlling roll is actually controlling roll, and just plug one at a time until on Cleanflight you see that roll moving with the stick that it should be moving. Then move next to pitch. Leave the roll one in and go through the rest until you find the pitch one. And this is just really a trial and error method, and it's a very easy method. And once you've done that and you've got them all in, you should basically have your thrust on, your throttle on throttle, your yaw on yaw, your roll on roll, and your pitch on your pitch. And then this switch should be your auxiliary 1, and then this switch should be your auxiliary 2, but on mine it's not working, but it should be. So this is all good, and now we need to flip to the modes tab, and we want to add a range for the arm switch. Now this all might seem very confusing if you've never done it before, but it's super simple. Basically we want to go add range on auxiliary 1, because we assigned this switch to auxiliary 1 inside the transmitter. And then you can see here this little yellow line, and when you flick it, the yellow line moves, so we know we're on the right aux channel. When the yellow marker is inside the yellow bar, it means that the flight controller will arm. So obviously when the switch is in that position, we don't want it to arm. If I moved it here, it would be armed in that position, but no, we don't want that. So we want it to arm when it's in the other position. One thing is, the default is 1500 in the middle. So if it's getting no signal, it'll go to 1500. Now, if it's getting no signal, I would kind of prefer it to disarm. So yeah, I'm gonna set it here and click save. And now you can see that arm is turning green when I flick it, and then red, green, red. And that's basically all there is to the setup. It's really quite simple. I would suggest we go back to the configuration page and click on save and reboot. And now you can see that if we arm and push the throttle, hey, it's working. So now we're good to actually put the rest of the body together and take it for a flight.